Hello guys, so we are back again, and in this session we are going to continue with the type 3, which was of type yf of xy into dx plus xg xy into dy equal to 0 form type problems. So in type 3 we have completed two problems. I've told you the direct trick in the end, how to identify directly these type of problems without going for homogeneity and other things. Now I want to mention there can be a situation where a question can be solved by two ways. Okay, then it's up to you how you can solve. Like the question is homogeneous. Okay, homogeneous, and it is like here uh, means in the further also when you will see some more types. Okay, it will be combination of two types like homogeneous and type 5. Okay, then you have to go with the simple one, which one is more suitable in that. Okay, what I'm talking about you will not understand for the time in now, but in the next sessions as we move on proceed, you will clearly understand what we are going to come across. So let's take the problems in this session, some more problems. So the first question which we are going to take in this session is dy by dx equals to minus x square y cube plus 2y the whole upon 2x minus 2x cube y square. First thing, what and how we will solve this. Second thing is that is its differential is coming similar to this. Okay, to identify whether we need to multiply this or not, it depends upon the differentiation. If its differentiation is entirely different from this, then you will multiply. But if the differentiation becomes similar to this, just 2 4 number like this are varied, then we will not multiply. I have told you the reason also in the previous lectures. Now how we will proceed. So I know its differentiation is entirely different. Whatever you respect to, you differentiate. Like here, if I differentiate the first one with respect to y, so 3y square and y, sorry 2. And here, if I differentiate the denominator with respect to y, I have minus 4x cube y. So they are entirely different. This is entirely different. This is entirely different. If it was something like 9x square y square plus 6, then I would have considered, but this is entirely different, so we will multiply this. Now if I multiply, what I am going to get, we are going to get something like 2x minus 2x cube y square into dy, and here we will get x square y cube plus 2y into dx. After this, what we are going to do, we will move it that side, which will give me something like x square x x cube is here, right? We will have y cube. Okay, so x square y cube plus 2y dx plus 2x minus 2x cube y square dy equal to 0. We got this. So this is our required general form, m of x comma y dx plus n of x comma y dy equal to 0. Comparing, what we get, so we got this, which clearly tells us that Therefore this is not an exact differential equation. After this, what we can do, if this is not an exact differential equation, however the given differential equation can be expressed in the form, which form? yf of xy into dx x into g of xy into dy equal to 0. So if we try to express it in this format, we will have y x square y square plus 2 dx plus x into 2 minus 2x square y square into dy equal to 0. If you are able to express it in this format. Now, after this, what you can see, therefore, what we will try to get? Ym, which is nothing but x into, what was our m was nothing but x square y cube plus 2y, what is minus, okay, minus, what is n? N is what? 2x minus 2x cube y square. If I multiply, so you can clearly make out 3x cube y cube. So we are getting this 3x cube y cube, which is not equal to 0, which is what we needed to prove. Now, integrating factor is nothing but 1 upon xm minus ym, 1 upon 3x cube y cube. Therefore, multiplying given differential equation with integrating factor 1 upon 3x cube y cube, what we are going to get? We are going to get something like, if you multiply first 3x cube y cube, let me write the things, which is x square y cube plus 2y dx, 2x minus 2x cube y square dy equal to 0. If I move it that side, we are going to finally be left with 1 upon x plus, okay, this 3 we have moved it that side, okay, don't consider it, because in the end if you multiply it throughout also, you have to remove it because it will be present in all the terms. So that is stupidity if you continue using that 3. Just think that 3 is not there and multiply by x cube y cube. So here x will be left and here 2 in the denominator x cube and y square, the whole dx. Then here 2 will be left, here x square y cube, 2 will be left and here 1 y and here dy equal to 0. So we are getting something like this, and this is the exact differential equation. How its solution is given by y constant, integration of dx, terms free from x, only one term minus 2 by y into dy equal to 0. Just integrate it. If you integrate log x and here what you have, 2x power minus 2 the whole upon minus 2 into 2 by y square minus 2 log y equal to c. So you are getting this thing. After this, what you can do, you can get log x minus x square into y square minus 2 log y equal to c. This you can write a log x by y, log x by y square. This 2 will move in the top. Okay, but that is just a manipulation. So this is our answer. Now let's move on to the next question. So the next question which we are going to take, let me change the pen. So the next question is solve what? Y into xy plus 2 x square y square dx into xy minus x square y square dy. Remember, it is not necessary that they will always give you y separately, x separately. They can give you attached also. There also you have to use that trick which I told you. Okay, let me just simplify this, because both equations are properly used. Okay, this format is also used and this also used when we want to express it. Therefore, so here you see in the dx bracket, I told you y power will be more than x always. Here y cube then x square, y square then x power 1. Here in dy bracket x power will be more, like x square y1, x cube y square. Okay, so you can make out. Now comparing the given differential equation with equal to 0, we get what we are going to get. We are going to get something like x y square plus 2x square y cube. Secondly, therefore x. So we got these two things, but you can clearly make out they are not equal. Therefore however, the given differential equation can be expressed in which format? Let's express the question in the starting was given in that format only. So you just need to write that. Okay. So minus x square y square into dy equal to 0. Now what you can see that we have expressed is, now our next job is to get what? Integrating factor. For that we need to prove xf minus yn should not be equal to 0. For that we need to first multiply y cube y square. If we further multiply, what we have? X square y square 2x cube y cube minus x square y square plus x cube y cube. What you can see, This and this will cancel out. You will be left with 3x cube y cube, which is your, and which is not equal to 0. Therefore, the integrating factor is equal to 1 upon xm minus yn is 1 upon 3x cube y cube. Therefore, what we are going to do? Multiply given differential equation with the integrating factor 1 upon 3x cube y cube. 1 upon 3x cube y cube is nothing but what it is, xy square plus 2x square y cube into dx plus x square y minus x cube y square into dy equal to 0. After this, if you multiply it, what we are getting? Just forget there is 1 3 because you will multiply and it will become 0. So what we have here is 1 upon x square and 1 y. In the second you have 1x here and that's it. Here you have 1x here and y square here. Here you have 1 by y here and dy. Therefore, the above differential equation is exact and its solution is given by what? That m of x formula. So which is y constant xy dy integral terms of n of x comma y free from x into dy equals to constant. Just write the formula. So we have x square y 2 by x. Sorry, let me use this here. So, okay. So 1 upon what it is, x square y, and it is dx, and remember y is constant. Then terms free from x, which is only one term, 1 by y, and dy equals to constant. If you integrate, you will get answer minus 1 by xy, and here if you integrate, it will be 2 log x, and here it will be minus log y. Okay, after this minus 1 by xy, first log x square minus log y, further minus 1 by xy plus log x square by y. So this is your answer. Now let's take the last question on the type 3. After this we will just end the type 3. So let's begin with the last question. So the last question is as follow. The question says, this question should be y xy sine xy plus cos xy bracket close dx plus x into box xy sine xy minus cos xy into bracket dy should be equal to 0. This is your required thing. Now comparing given differential equation with what, m of x comma y into dx plus n of x comma y with dy equal to 0, we get m of x comma y is nothing but x y square sin xy plus y cos xy, and n x comma y is nothing but x square y sin xy minus x cos xy. Now dm by dy is nothing but x will be as it is, so first if I integrate 2xy sin xy, first product rule will be applied. Secondly, here it will be x y square cos xy. If y is eliminated, x will be left, which will give me final answer 2xy sin xy plus x square y square cos xy. After this we will do the dn by dx, which will be 2xy sin xy plus x square y cos xy into y, which will give me further on. Okay, wait, here in the differentiation of this we have forgot this y1. If I do it, it will be first cos xy, and after that it will be y minus sin xy, right, into x. So we are going to get, sorry, we have written here, just do one thing, this part belongs to here. Okay, after this what will happen is actually this will be as it is, and this xy will cancel out with this one. And let me change the pen so that this can be understood that we are writing. So here this cos xy will be as it is, and this minus xy sin xy will cancel it out this once, and we will be left with xy sin xy plus xy square y square cos xy, and lastly we will have plus cos xy. So hope you have understand this. Now in this one here we have done the differentiation of the first part, which is this one, properly. Now we will do the differentiation of the second part. Here minus will be as it is, cos xy will be left. In the next, minus x will be as it is, here minus sin xy will be there, into x will be eliminated, y will be there. Finally we are going to get 2xy sin xy, x square y cos xy minus cos xy plus xy sin xy. You can clearly see they will add on, and this will become 3 xy sin xy plus x square y square cos xy. Now you can clearly make out that they are entirely different. Therefore dou m by dou y is not equal to dou n by dou x. Therefore the given differential equation is not exact. After this, what our next job is? Our next job is to that it can be expressed. Okay, however it can be expressed in the form, which form we are talking about, y f of xy dx x g of xy dy equal to 0 form. Therefore let's write the in this format. What will it will be in this format? Y xy sin xy plus cos xy into dx plus x into bracket xy sin xy minus cos xy into dy equal to 0. After this, what we can do? Go for xm minus ym. So xm minus yn will be nothing but x into m, which is xy square sine xy plus y cos xy minus y into x square y sine xy minus x cos xy. After this, what we are going to get? X square y square sine xy plus xy cos xy minus x square y square sine xy plus xy cos xy. So 2 cos xy and this will nullify. So we are getting this, therefore integrating factor which is not equal to 0 equals to 1 upon xm minus yn, which is 1 upon 2xy cos xy. After doing this, what we can make out from this is that 1 upon 2xy cos xy is nothing but bracket x y square sine plus y cos xy dy, sorry dx, plus minus dy equal to 0. Now what we can do, okay, just forget about this two part, it is of no use. Just think that we have moved it that side. If we divide it by 2, what we are going to get? In this will become y, 1y will become tan xy, right? And here 1y will cancel out, x will be there in the denominator and cos will cancel out. So 1 upon x, the whole dx, and here 1x will cancel out, but 1x will be there and x tan xy, and in the top with minus and 1 by y, and this will be what? Your dy equal to 0. Therefore the above differential equation is a exact differential equation, and its solution is given by, how we will give integration y constant y tan xy plus 1 by x into dx term free from x, which is minus 1 by y, dy equal to constant. If you do, you know the integration of tan xy? It is very simple, log sec, okay, integration tan ax dx is what? It is nothing but log sec ax upon a. So if we do this, what? Log sec xy the whole upon, if you differentiate with respect to xy, you will get y here, and here log x, and here minus log y. Okay, I will write the formula here. You may not know the formula. Integration of tan ax dx is nothing but log bracket sec ax the whole upon a. Now so it may be the scene that you don't know sec ax the whole upon it. So this was the formula which we used, and y will cancel out from here. Here we will be left with log sec xy log x by y equals to c. So this is our answer. So with this question we are done with the type 3, and in the next session we are going to move with the type 4. Till then, practice all the types of the problems and see you in the next lecture.